Hello and good day to all of you. My name is NAZREEN SYAHIRAH binti Abdullah and my metric number 191092342. So today I'm going to talk about my part. I have two main points to present. So the first one is introduction and background study. The second one is theory. Rising population, rising energy consumption, climate change, and peak oil are all hastening the search for valuable alternatives to fossil fuel. Renewable energy sources such as wind and solar are well-known, use dependable technology and have established markets. Other renewable technologies in development show promise for meeting a portion of future electricity needs. Many governments are encouraging this search by establishing mandatory goals for diversifying their energy resources by specific deadlines and pledging to devote a greater proportion of their energy consumption to renewables. Tidal energy is produced by the relative motion of the Earth, Sun and Moon, which interact via gravitational forces. The Sun and Moon gravitational attraction causes periodic changes in water level and associated tidal current. This phenomenon is used to generate energy by a tidal energy generator. The greater the strength of the tide as measured by water level, high or tidal current velocity, the greater the potential for tidal energy generation. This loss of energy has caused the Earth's rotation to slow over the 4.5 billion years since its formation. Over the last 620 million years, the Earth's rotational period has increased from 21.9 hours to the current 24 hours. During this time, the Earth has lost 70% of its rotational energy, while tidal power may draw additional energy from the system, increasing the rate of slowdown. The effect will be noticeable only over millions of years, making it insignificant. Tidal energy is a type of hydropower that converts tide energy into electricity or other form of useful power. It is also a renewable source of energy that does not result in the emission of greenhouse gases or SYAHIRAH that associated with fossil fuel generate electricity. The use of tidal energy could also reduce the need for nuclear power, which comes with its own set of radiation risks. The energy of the tide is derived from the Earth's rotational energy. This energy can be used to generate electricity using a tidal generator. Large underwater turbines are placed in areas with high tidal movement and are designed to capture the kinetic motion of ocean, tide ebbing and surging in order to generate electricity. This is an example of a block diagram of tidal power generation. There are three examples about tidal power generation, which is a tidal barrage, tidal turbine, and tidal lagoons. So first of all, I will share about tidal turbine first. Tidal turbines are powered by the same technology as wind turbine. The only difference is that tidal turbine blades are much stronger and shorter. So underwater windmills are the best way to compare tidal turbine. In an ideal world, the water current will turn the turbine. A shaft connects the turbine to the generator. As a result, when the turbine turns, so does the shaft. The turning shaft turns on a generator which produces electricity. The initial cost of establishing this tidal stream system is quite high. Not to mention the difficulty in maintaining it. A tidal barrage is a dam constructed across an estuary or bay to generate electricity from the tidal flow. It operates on the same principles that are used in the production of conventional hydroelectric power. Besides, a conventional dam which dams water on one side, a tidal barrage allows water to flow into a bay or river during high tide and release it during a low tide. This is accomplished by measuring the tidal flow and controlling the sluice gate at critical tidal cycle time. Turbines are installed at these sluices to capture the energy generated by the water as it flows in and out. Tidal lagoons like tidal barrage capture a large volume of water behind a man-made structure and then release it to drive turbine and generate electricity. This causes a difference in water level height between the lagoon's interior and the sea. Once the difference in water level has been optimized, the wicket gates are opened and the water rushes into the lagoon via bulb turbine mounted inside concrete turbine housing in a section of the breakwater wall. Electricity is generated as the water turns the turbine.
Assalamualaikum, and my name is NURUL BINTI. My address is 191092351. I'm going to present the mathematical modeling part for tidal power generation. Okay, the total tidal energy is the sum of the energy due to the release of the stored energy of water in the basin, which is known as potential energy, and the kinetic energy due to the tidal stream, which is known as kinetic energy. The increase in tidal stream energy results in increase of energy extraction to the large extent. The potential energy can be calculated as E equal to 1/2 times A times rho times G and times H squared, where A is known as bearish basin horizontal area, rho is known as water density is equal to 1205 kg/meter cube. Seawater varies between 1201 to 1030 kg/meter cube. G is known as acceleration due to the Earth's gravity, which is equal to 9.81 meter over s squared. H is equal to the acceleration range. The kinetic energy can be calculated using the formula P equal to 1/2 times by C P times by rho times by A and times by V cube, where Cp is known as the power coefficient and rho is known as the density of water, A is known as the channel cross-sectional area, and V is equal to the current velocity. Okay, to calculate turbine power output or efficiency is using formula P equal to epsilon times by rho times by A times by V cube over 2, where P is power generated in watt and epsilon is known as turbine efficiency or power output. Rho is water density of seawater, and A is equal to turbine sweep area, and V is velocity of the flow. That's all my part for mathematical modeling of tidal power generation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURLIYANA binti Zulkifli. My metric number is 1910923350. I am from RK23. Our group topics for this assignment is tidal power generation. I am going to present about how many of the population got access to the electricity produced. Okay, Malaysia is heavily reliant on fossil fuels to meet its energy needs, and this dependence is growing year by year. As a developing country, Malaysia's population increased over the year with an annual growth rate of 1.8%, and it is expected will reach 33.4 million by the year 2020 and approximately 37.4 million in 2030. In 2009, the total electrical energy generated was 103.2 terawatt-hour, and the demand is expected to increase by 4.7% per annum to 274 terawatt-hour by the year 2030. Because the ocean covers 70% of the Earth's surface, it has become one of the world's renewable energy sources. The potential and commercial viability of harnessing tidal energy in Malaysia has not been thoroughly investigated until recently. A preliminary study was conducted to investigate the feasibility of harnessing tidal energy for electricity generation in Malaysia. The average electricity consumption in Malaysia is assumed 3966 kilowatt-hour per household annually. By using assumed electricity consumption, the amount of electricity demands by local population is calculated and shown in table. As you can see, the table shows the local electricity demand. From this table, the highest electricity demand is Kota Kinabalu, followed by Tawau, Pulau Pinang, Sandakan, Bintulu, Lahad Datu, and Pulau Langkawi, which is the demands exceed more than 100 gigawatt-hour annually, while the rest locations are below 100 gigawatt-hour. Next, when the output power generation is calculated using the suggested tidal basin area, the result is compared to the local demand and the number of households in that location. This is comparable to see how much electricity could be generated by harnessing tidal energy for the local population. These tables show number of houses supplied by tidal energy and percentage of contribution. As you can see, Labuan has the lowest output power generation with 0.04 gigawatt-hour of power generated, only 10 houses supplied by output power generated, and a contribution percentage of 0.05%. Pulau Langkawi has the highest power generation and percentage of contribution with an output power generation of 2.99 gigawatt-hour and the ability to supply 753 houses with 2.90% contribution from the total number of households in that area. The rest is followed by Lahad Datu with 1.28 gigawatt-hour, 322 households supplied.
Assalamualaikum warahmatullahi wabarakatuh. My name is NAJIHAH binti Zulkifli. Metric number 1910923340. I will present the percentage of tidal power generation in energy mix. Tidal power is renewable energy powered by the natural rise and fall of ocean tides and current. In the global electricity scenario, ocean renewable energy has contribution up to 7%. In comparison, tidal stream and offshore wind technique together account for around 0.75% of global energy needs. The total energy contained in the tides in the world is 3,000 gigawatt. Although estimate of the amount of energy available to generate electricity from the tidal barrages are between 120 and 400 gigawatt, according to the location and commercial possibility. Next, the tidal power plant in the world. First, a production with capacity of 254 megawatt. The Lake Shinhua tidal power plant on Lake Shinhua, about 4 km from Shinhui City in the South Korea province of Gyeonggi, is the largest tidal power plant in the world. Second, the 240 megawatt La Rance tidal power station on the Rance estuary in Brittany, France, has been in service since 1966, making it the oldest and the second largest tidal power station in the world. Third, the Annapolis tidal power station, located in the Annapolis Basin, A sub-basin of the Bay of Fundy in Canada has an installed capacity of 20 MW, making it the third largest tidal power station in the world.
Next point is, are there any government's commitment towards promoting a sustainable and cleaner production of the type of power generation, which is for our topic assignment is tidal power generation. The use of fossil fuels poses a serious threat to global warming and climate change because there has recently been a strong global trend toward green power. Green energy sources such as solar, wind, hydro, tidal, and wave have distinct potentialities in terms of geographical location, social and economic viability, and environmental acceptance. Tidal power is a green energy source with numerous potentials and benefits. It does not produce any greenhouse gas. Besides, it has the characteristics such as very high lifetime, typically exceeding 120 years. Tidal power has high capital cost, but the long-term maintenance cost is almost zero. It produces no waste streams and non-fuel operating capacity. Tidal power is a form of hydroelectric generation in which the water resource is replenished by tidal movements. It is truly renewable green power and clean source of energy, creating no pollution and thereby helping to reduce greenhouse gas emissions, which is simple, reliable, and predictable. Some promoting barriers to tidal power generation can be overcome. First, information type approaches on tidal power generation. To enter any market, consumers, suppliers, and other market participants must be aware of the existence of a product. Tidal power as a green electricity option for all customers is still not widely known, and consumers need to be informed and educated about green electricity options. The existing of power content label is also important, and it allows consumers to easily compare the power content of one supplier to that of another, thereby providing transparency, consumer choice, and education. Other than that, funding initiative of tidal power generation. Tidal power is considered a global public good. A global initiative to fund and implement clean, environmentally sound, and renewable tidal power projects around the world is required. These funding initiatives could come from a variety of sources such as GEF, which is Green Environment Fund financing, development finance, new financial mechanisms, and other prospective sources for financial assistance. That's all from me. Thank you.
This is the comparison of the three tidal power stations. First, Shinhua Lake Tidal Power Plant with capacity of 254 MW and annual generation output is 553 GWh. It was opened in August 2011 and with the help of 10 bulk turbine, electricity is generated from the tidal inflows into 30 km² basin. The power plant site has an average tidal range of 5.6 meters. Next, La Rance Tidal Power Plant with the capacity of 240 MW and annual generation output is 549 GWh. It was opened in 1966 and with the help of 24 bulk turbine, electricity is generated from the tidal inflows into the 22 km² basin. The power plant site has an average tidal range of 8.2 meters, highest in France. Then, Annapolis Tidal Power Plant with capacity of 20 MW and annual generation output is 50 GWh. It was opened in 1984 and with the help of one wind turbine, electricity is generated from the tidal inflows into the 50 km² basin. The power plant site has an average tidal range of 6.4 meters.
My name is NURUL. I'm going to continue the discussion part. Every energy source has their own gains and losses. Tidal power generation is like all the other energy source has its own benefits and weakness. And one of the benefits is that energy is a renewable resources that use the power of the sea and it does not diminish as it is consumed. And it is also cleaner than fossil fuel. This is due to the tidal power station does not release any greenhouse gases during electricity generation. Next, the power of the tide is highly predictable. Unlike sun and wind, low and high tides follow a series of cycles and making it easy to predict when electricity will be generated throughout the day. Aside from that, tidal power facilities can generate large amount of electricity. One of the primary reasons for this is because water is extremely dense, approximately 800 times denser than air. Due to this reason, even if the water conditions are not optimum, tidal turbines have the ability to generate large amount of electricity. On the other hand, there are several disadvantages of tidal power generation. One of the weaknesses of this energy are sites for installation are limited. The possible installation site must meet very precise requirements in order for a tidal power generation to be developed. For starters, they must be positioned along a coastline, which limits suitable station location to coastal states. Next, most significant weakness of tidal power is the expensive initial investment. Because of the high density of water, tidal energy turbine must be substantially more durable than water turbine. The cost to build a tidal power generation plants varies based on technology used. Okay, the construction of tidal barrage is extremely expensive, as is require the installation of an entire concrete structure as well as turbine. So the cost barrier is one of the primary reasons for the slow adoption of tidal power plant. Okay, every installation and operation of power generation will have either positive or negative impacts, especially towards environment. It should be not forgotten that one of the benefits of constructing tidal power plant is they minimize carbon emission. However, the most well-publicized effect of tidal barrage is the possible loss of some habitat. The benthic habitat may alter due to change in bottom stress caused by wave and current. Migratory fish may be hampered despite the fact that fish passage can be good. Collision with the barrage and turbine may cause harm and marine mammals. Will cause harm to fish and marine mammals. That's all from me. The discussion of tidal power generation. Thank you.
As conclusion, tidal energy is a type of renewable energy with high potential. Tidal energy represents an important opportunity to increase the capacity of renewable energy production in the world. As countries continue to develop, the world population and its dependence on energy increase. So thus the demand for a power system to provide additional clean energy resources application can be brought successfully. Water is 100 of times denser than air, making tidal energy more powerful than wind. It is more efficient than wind or solar energy due to its relative density and does not produce greenhouse gases or other waste, making it the attractive renewable energy source to exploit. While clean and renewable resources also preserve the world's natural resources, they also reduce the risk of environmental disaster.